Hey guys, we're going to quickly go through these notes for central tendency, measures of central tendency. So measures of central tendency is a fancy way of saying finding one value that best represents kind of the entire data set. So we've seen these growing up lots of times. This isn't the first time you've seen these kind of things. Most of the time you have referred to it as the average, or you might have heard something being referred to as sort of more typical or most typical. And usually we have one of three ways to find this value, right? So we can find what we call the mean. The mean is what we are used to calling the average. This is what we learned in sort of third grade, how to kind of find an average. Instead of calling that average, we're going to call that mean. So average could be more than one. It could be any one of these three things we're just about to talk about. So instead of, we're going to be more specific and say we want to know the mean. So the mean is just what we're used to seeing, something like, whoops. Sorry, there we go. The sum of the values divided by what, the number of values, right? The count, or the number of values. The number of values. So this is what we're used to finding when we talk about average. So the next one is this median. The median is the middle number. The middle number, if we sort all the data from smallest to biggest. So middle number when we sort, when the data or the values, the data is sorted, smallest to biggest, right? Smallest to biggest. Right, so we just find the one that's right smack dab in the middle. If there isn't one in the middle, like say we have an even number of data, right, even number of values, then we just take the mean of the two in the middle. Right, so that's all there is to it. So we'll get some exercise doing this in just a second. So the final one is this mode, right? So what's a mode? Well, a mode is, first of all, let me get rid of this stuff a little bit. A mode is just the value that happens the most often, right? That happens the most often. Value that happens the most often. So sometimes this is useful. Sometimes we use this and we say most typical. This is really what we mean is the mode, right? Value that happens the most often. So that's why we have to be pretty careful when we talk about averages, because it could be any one of these averages. It could be one of these three. So let's get some practice. So here's a little data set: 10, 11, 15, 12, and 10. So let's just find that average here. So we got 10 plus 11 plus 15 plus 12 plus 10. Oops, it's kind of ugly. All divided by, this is a plus sign right here, plus, divided by, I think it's 5. 1, 2, 3, 4, 5. Yep, plus 5. That equals, I think it's like 11.6, something like that. I've done this a couple times, and I think that's the right answer, 11.6, so you can check. Let me know if I get that wrong. Alright, so that's pretty easy. This is what we're used to doing. Nothing fancy here. We know what's going on here. So the next one is this median. So the first step in the median is to sort the data from smallest to biggest. So here we go. We have a 10. We're just sorting the data. 10 and another 10. And then we have an 11. And then we have a 12. And then finally we have a 15. And so then we find the data that's the data point that's right in the middle. So here it is, 11. Right? So this is 6 is our mean. 11 is our median. Right? Because it's just the value right in the middle. So right away we can see 11 actually occurs in this data set. 11.6 does not. Right? So there's one thing that's a little bit different. If we want to actually have a value that actually occurs, it's more likely to happen if we use the median. Not always, but more likely. Okay, so the next one, the mode. So with the mode, what we have to do is just count how many times things occur, right? So here we go. We have a 10, and we have a 10, we have an 11, a 12, and a 15. So we have two 10s, one 11, one 12, and one 15. So since there's two 10s and only one of the rest, then the mode is 10, right? All right, we can just do that because there's a 10 here, 11, 11, 12. So this is pretty simple, just because there's two 10s. So we just find the one that happens more than any other values, right? So 10 happens more than any other value. All right, so let's do another little exercise, this next one. Our new data set is 10, 11, 15, 120, 10, and 11. All right, so let's see if I can remember all those. 10, 11, 15, I'm going to forget them. It's doable anyway, so we have 10 plus 11 plus, I think there's another 10 in there, plus 120, and then plus, there's another 11, I think 1, 2, 3, 4, 5, I think there's one more, I think it's like 15 maybe? Yep, 15. I got these in way wrong order, but this is how my memory works. I can't remember too far in advance. And then in this case, we're going to divide by 6. Like 1, 2, 3, 4, 5, 6. And I think the answer is something like 29.5 or something like that. It doesn't matter so much. We can calculate this. This is pretty easy to do. So that's interesting. So this answer 29.5 is quite a bit different than the answer we had before, 11.6, right? And although this data set is pretty similar, the only real difference is we have this 120 here instead of a 12. Right, so that's interesting. So the mean changed quite a bit. So let's see what happens to the median. Alright, so let's sort this data again. So here we have a 10, another 10, we have an 11, we actually have 2 11s this time, a 15, and then 120. Alright, so smallest to biggest. Now, right in the middle, well, the middle is right here. There's not actually a value right in the middle. But we can just take the 2 values around the middle. Alright, so these 2 11s. Oh, gosh. Alright. Still learning this stuff. 2 11s right here. And take the average, take the mean of those two, right? So the mean actually equals 11. The mean of 11 and 11 equals 11. So the median is 11, right? So this is interesting. So the median is 11, which it was the same up above, right? So the median was 11 here too, right? So the median hasn't changed, even though we have this really big number 12, or 120. So finally, let's do the mode. So the mode, all right, well, the mode is the one that happens the most often. Well, we have a 10 and a 10, an 11 and 11, a 15 and 120. So it's not 15 and 120, but these two both have 2 values, 10s and 11s. So what do we say? Well, we actually say that this is, we'd say bimodal. Bimodal, which just means we have 2 modes, right? Which is okay. This happens sometimes. So we just say, well, the mode is 10 and 11. Right? 10 and 11. All right, so that's fine. All right, so this next few sections here, it talks about M&Ms. We're going to do this in class. So let's skip these screens. We're going to go all the way down here to this part. So what are the advantages and disadvantages of each of these measures? Well, let's talk about the mean. So the advantage of the mean is we use all the data, or all the values, to calculate this, right? So we capture all of the values in order to do this. This is opposed to, it's one of the disadvantages of the mean. These are always, the median, is that it only uses 1 or maybe 2 values, right? So it only uses the one that's right in the middle or the 2 that are surrounding the middle. And so sometimes it might not be very representative of the median, whereas the mean, the mean does a better, sort of a little bit better job of using all of the values. So that being said, though, one of the disadvantages of the mean is that it's influenced by the outliers, right? Influenced by outliers. Oops, outliers. There's an outlier. So what is an outlier? An outlier is just some number that just doesn't really seem to fit with the other, right? One of these things just doesn't belong. So, like the 120 was really big, right? So it kind of screwed up the mean, right? But it actually didn't really change the median that much. So that's one of the advantages of the median is that it's not influenced by outliers, right? Okay. All right, so we'll probably think of some other advantages and disadvantages of the mean and the median. Finally, this mode. Well, when do we use this poor little mode? So the mode isn't used very much. It's used mostly with sort of descriptive data or descriptive value. So this is oh gosh, sorry, keep pushing this little button. Descriptive. This is a descriptive value. So instead of numeric values, some other type of descriptive or nominal type of values, we would use the mode. So if we wanted to know what's the most typical color in an M&M bag, that would be a mode, right? This is an average, just like any others, but we can't calculate an average using some sort of numeric technique instead of using a mode. All right, so quickly here, we're going to intro into math notations just to help us understand in the future what some of these sort of notations that we see in our textbook, and that we'll talk about later on what these mean. So this guy, this is a big, what we call big N. All right, this is a little n. What we're using so far. Big N equals the population sample size. So the entire, no, not sample size, the population size. The entire size of the population, I mean, the count of the population, how big it is, right? That's what big N is. Little n is the sample size, right? Or a sample size. So we haven't really talked a whole lot yet about population versus sample, but population just means the entire, all the possible values that are out there in some sort of, depending on the type of data, every single thing that could ever be collected on this one thing that we're thinking about. Whereas a sample is just like some small little subset of it, right? So we just notate the sample. If we're dealing with populations, we're looking at this big N, and if we're concerned about sort of samples, then we're looking at little n. So that's all that means. All right. So this guy right here, this next one, is what we call mu. Oops. Sorry. Let's try again. So this is mu, moving things over. Mu, like a cat. Mu is the population mean. Population mean. Right. So this guy right here, we call him x bar. X bar, right? Because it's got an x with a bar over it. Right? So this is mu, x over a bar. And this is the sample. So far, nothing really exciting here. But let's talk again. When we see this mu thing, you know we're talking about populations. And when you see this x bar guy, you know we're talking about samples, right? So that's why we have two different ones. All right. So the next kind of thing that's weird is this little x guy. When we talk about him, we see this is an x xi. Maybe we can write it this way: xi. And what is an xi? An xi is just some value. At the sort of, we can think of this at the ith point, position. Ith position. So what does that mean? So that means if I have 10 different values, just think of this, 10 values, and this is an example, 10 values, I actually have 10 positions where these can sort of be sitting, right? The first position, the second position, the third position. So xi, we're going to use to say, well, what is the ith position? What's the value in the ith position? We can say, oh, so I can say, well, what's x sub 3, right? That's the value at the third position, right? Where I equals 3. So that's all that is. And we're going to use that in just a second. So here we go. This final guy is a summation sign, right? So, did it again. This is a summation sign. Summation, I think I wrote that down. Summation sign, I think that's spelled wrong. That's right. Summation sign is also a sigma. Summation sign. And we're going to use this in just a second, you'll see, to sum up a whole bunch of numbers. It's just kind of like a little program that's going to go through and sum a bunch of things. Alright, so let's write this, what a mean of a population would look like if we were going to use this notation. So if you remember, if we're talking about populations, we're going to talk about this mu guy. Alright, so mu, and we're going to say mu equals something. So mu equals, well, we're going to sum up a whole bunch of numbers. Alright, we're going to call those xi's. And we're going to divide that by what? Big N. Right? So here's our xi's. And we're going to say, this is how we write this, I equals 1 to big N. So this is the sum right here. It means that we're going to look at all of the values that go from 1 to n, right? All the positions from 1 to n, and we're going to sum all the values, these xi's in there, right? So let's say I have 10 numbers, I'm going to go see what's x sub 1, add it to x sub 2, add it to x sub 3, and this is, so this guy right here, that we see every time we see this summation sign, just think, oh, this is like a little program that's just going through and adding a whole bunch of things together, right? And then when we're all done with that, we divide it by big N. So this is just the mean, right? What we're used to seeing, mean of a population. So what does the mean of a sample? Well, it's exactly the same thing, except for we're going to use different notation. Instead of mu, we're going to say x bar. And we're going to say the sum of xi's divided by, instead of big N, we're going to divide by little n. I equals 1 to little n. Right, same thing. This little guy right here, this summation sign, is sort of like, you can think of this little program going through and adding all these xi's, and then at the end we're going to divide it by the little n, just the sample size, and we get an x bar. Alright, so that's it for this video. See you in class.